Unit 4.11, the last one for Unit 4. And this is just digging a little further into the idea of parallel and perpendicular. Right, now that we know what a parallel and perpendicular equation looks like, we can create our own. Right? So, given a linear equation at a certain point, you can create another equation that passes through this point and is either parallel or perpendicular to the given line. Right? So now that we know this new information about parallel and perpendicular equations, about the slope, we can use that information. Right? Keep in mind, parallel lines have the same slope. They have the same slopes. Parallel lines have the same slopes. And perpendicular lines have negative reciprocal slopes. Right? So for example, parallel would be y equals 2x plus 3 and y equals 2x minus 6. Because they have the same slopes, they're parallel. And perpendicular would be y equals 2x plus 3 and y equals negative 1 over 2x minus 6. Because they're negative reciprocal slopes. You flip the fraction and switch the sign.
Ms. Oliver, please buzz Ms. Reese on her IP. Ms. Oliver, call Ms. Reese on her IP.
All right, parallel examples. I do odd, you do even. All right, it says, write the equation of the line that passes through the point negative 2, 7 and is parallel to the line y equals negative 4x plus 1. So how would we do this? If we have the point and the slope, we would use the point-slope formula. We have the point, and because we want it to be parallel, we have the slope. Slope has to be negative 4. So we have point and slope. All we have to do is plug it into the point-slope formula. All right, so what's the point-slope formula? Y minus y1, right? x1, y1, just labeling it, just so you can see it. Y minus y1 is equal to m x minus x1. So y minus 7 equals negative 4x. This becomes positive. Negative 4 and positive 2 is negative 8. Add 7 to both sides. Y equals negative 4x minus 1. We just created a whole another equation that's parallel. And it passes through this specific point. Right? If they give you a point and the slope, put it in the point-slope formula. Before you look for the slope on this one, you might want to convert it to slope-intercept form. Okay, so we're passing through 4, 3, x1, y1, and it's perpendicular, so we want a negative reciprocal slope. So if the slope is 2, then our new slope, our negative reciprocal slope, is going to be 1 over 2, switch the sign. Flip the fraction, switch the sign. That's negative reciprocal. All right? Now that we know the point and the slope, we can create our new line. Y minus y1 equals m x minus x1. Y minus 3 equals negative 1 over half x. Negative 4 divided by 2 is negative 2. Negative 1 times negative 2 is positive 2. Add 3 to both sides. y equals negative 1/2 x plus 5. We just created a new equation that's perpendicular and crosses that point. All right, let's see what they're going to do. More practice. Write an equation passing through the point that is parallel to the given equation. All right, they're making it even easier for you. All right, point, slope. They want it to be parallel. So our slope is going to be 2. We need it to be the same. x1, y1. Y minus y1 equals mx minus x1. Y plus 1 equals 2x plus 4. Y plus 1 equals 2x plus 8 minus 1. Y equals 2x plus 7. We just created a parallel line that goes through that point. Again, this one is not in slope-intercept form. We need it to be y equals mx plus b so that we know the slope, because this is your slope. All right, so we need to convert it. We need to solve for y. This is a positive x, we're going to subtract x. That's negative 2y equals negative 1x plus 14. Divide by negative 2 to get rid of that. Y equals 1/2 x minus 7. All right, so what is our original slope? 1/2. We want a parallel line, so where our new slope is also going to be 1/2. So y minus y1 x equals m x minus x1. Y minus 5 equals 1/2 x, which is just 1/2 times x. And 4 divided by 2, negative 2. 1 times negative 2 is negative 2. Add 5 to both sides. Y equals 1/2 x plus 3. Bam, done. And see, it has the same slope. So you know it's parallel. This time it says do perpendicular. So we know we're going to do negative reciprocal. It's already in slope-intercept form, right? We want the negative reciprocal. So we're going to flip the fraction and change the sign. This is the slope we're going to be working with. x1, y1, y minus y1 equals m x minus x1, y plus 3 equals negative 4 over 3x, negative 3, negative 3, negative 1, right? Because negative 3 over 3 is negative 1, right? Negative 4 times negative 1 is positive 4. Subtract 3 from both sides. Y equals negative 4 over 3x plus 1. Bam, done. This one needs to be converted. No big deal. x1, y1. We're going to solve for y. This is a positive 2x. We're going to subtract 2x. These are not like terms. We're just going to line them up. Divide by the 10. Y equals negative 1/5 x plus 2. And remember, we're going perpendicular, so our new slope is going to be flipped fraction, change sign. So instead of negative 1 over 5, it's going to be positive 5 over 1, which is 5. Right? Flip the fraction, switch the sign. So it's y minus y1 equals m x minus x1. So y minus 3 equals 5x minus 10, because 5 times negative 2 is negative 10. Add 3 to both sides. Y equals 5x minus 7. Good? I told you, now that we knew the rule, we could create our own parallel or perpendicular equations. Alright, so just a quick look at the ones that you're going to do in case you need to write them down. Write the equation of the line that passes through the point 3, negative 1 and is parallel to the line x minus 3y equals 9. Convert first. Write the equation of the line that passes through point negative 5, 1 and is perpendicular to the line 5x plus 3y equals negative 21. Convert it. 6 doesn't need to be converted, and we're doing parallel. 8 needs to be converted, and we're still doing parallel. 10 doesn't need to be converted, and we're doing perpendicular. And 12 needs to be converted, and we're still doing perpendicular. You got this. Congratulations, you finished.